This is a piston in Minecraft, and this is a massive real-life piston I built from over 7,000 Lego parts.
Wow.
It works just like a Minecraft piston, including interacting with redstone components like buttons, levers, and more. All the mechanisms are hidden inside, but I'll show you everything. You also get the bonus of seeing 3 other blocks I've never shown before, and I'll use them to make sure the piston only pushes the blocks it's supposed to. I'm hoping this is the coolest video you see today, so make sure to hit like. Let's get into it. Because it moves, this is the most important part of this build. I took notes about color and how many pixels each section has. The first thing you should know is that pixels in Minecraft match to Lego parts pretty easily. A brick with a plate and a tile creates a Lego pixel. Of course, the tricky part is matching color because of all the different shades, but if we take the general look of a block, usually there are Lego colors that match. I picked dark tan, light bluish gray, and dark brown. Now that I know how to make the block look just like Minecraft, here's how I'll get the piston to actually move. I'm going to use a fairly new Lego part that is perfect for this kind of mechanism. When the motor rotates, the screw moves this black block with the red tile up and down. I figured the piston would be heavy, so I added 4 sets of screws to distribute the load. Of course, I forgot that the screws should be supported on top, so I changed my first design to leave room for supporting beams. With that done, I started building the walls of the piston's connecting rod. That's this part, in case you're wondering. It needs to be hollow so the screws can rotate inside. But here's the thing, that doesn't make for a very strong build. Unless you use the SNOT technique. Yes, I said SNOT. No, I don't mean the stuff from your nose. SNOT stands for studs not on top, like this piece that has studs on the side. By interlocking bricks normally and using SNOT, you can create a very strong structure, even if it's hollow. That worked great on this side, and I'll use modified plates on this other side to get the same effect that SNOT has. See how the walls are going to collide with this modified plate though? Unfortunately, there isn't enough room here. Thankfully, Lego has panel pieces, which look like normal bricks on one side, but have cutouts on the other. This will give the space needed. Also, remember how the piston can push some blocks but not others? There's going to be a sensor in the piston that allows it to read what block is in front of it, so I need to run a cable inside this connecting rod. Thankfully, there's enough room behind the panel to do that too. I put together several more sections and connected them. Looking at the outside, you'd never know this was hollow, but with 4 screws, SNOT pieces, and a wire running all the way through, there's no room left. With that done, I started designing a strong frame for the rest of the piston. This is what I came up with. It's strong yet hollow to keep the piston as light as possible. I created 2 since one will be used later. I wanted the bottom of the piston to have a smooth finish and not show the bottom of the bricks, because that's what you see in Minecraft. Normally, you could use inverted tiles to do that, but those pieces aren't made in all the colors I needed. So instead, I used brackets to flip the direction I was building so I could use normal tiles instead. Wow, look, the piston is really starting to take shape. I added several more layers of bricks, always making sure that any part that would be seen on the outside was the right color. As I neared the top, I added an RFID sensor so the piston can detect what block is in front of it. That way it'll know if it's allowed to push that block or not. I finished the inside structure by adding the other Technic frame and using a technique kind of like Snot, except with Technic parts instead. In hindsight, I do not recommend this exact design because of how tricky it was to connect, but at the same time, the principle I used here makes the build extremely strong, so in some cases it's worth it. Finally, I tiled off the top of the piston to make it look just right. It's so cool. And check this out, if I hadn't used the Snot technique, there is no way I could shake the piston like this. In fact, here it is again with the Snot pieces removed. Yep, that's what I thought. Before moving on, let's make sure the piston can detect blocks in front of it. Here are two other blocks I made. This is a lodestone, and this is a birch log that's still a work in progress. They're a smaller scale than my normal blocks, but they'll work for this test. They both have an RFID card inside that can be detected by the piston. Remember, a piston cannot push a lodestone, but it can push a birch log, so let's just make sure it can detect them correctly.
That's a lodestone, but I cannot push it. That's a birch log, and I can push it.
Cool, that'll be perfect. Next, I put together the piston housing, following the same pixel and color ideas I used for the piston. I used Technic bricks on the corners, so that the places where colors don't overlap would be stronger. With the housing ready, a new problem made itself very apparent. Ah, Steve, you're as bad as a creeper when you hide like that.
Yeah.
Back to the issue at hand. You probably expected this because in Minecraft you can see that the connecting rod is 16 pixels, while the piston housing is only 12. I wanted to have the piston travel the length of a full block, so I had to come up with a plan to fix this issue. My first thought was that pistons are often placed on other blocks in Minecraft, so I decided to use chiseled stone bricks since they match the color scheme of the piston and you can still tell it's a distinct block from the piston. After modeling the chiseled stone brick block, I decided to start working on the piston's functions. Now remember, the piston is hollow, yet it still has over 2,000 pieces and weighs about 2.5 kilograms, or 5.5 pounds. That's pretty heavy, but I was just sure there'd be a way to lift it. So I got some motors and got to work. The first thing I realized is that all 4 screws needed to rotate in sync with each other. Here are 2 synced screws. If one of them skips a tooth, like I just simulated there, things start to get more and more out of whack until something breaks. With that in mind, I put together an initial design using 2 worm gears, but there were a few issues. First, I didn't gear down the motors enough to give them the power to lift the heavy piston, but they could lower it with the help of gravity. Second, when lifting the piston, the gears could slip and cause the screws to get out of sync. And finally, the weight of the piston on the screws causes the whole thing to twist, and that's a bad thing. So on my second design, I needed to fix those issues. First, I doubled the motors for more power. Then I doubled the gears to mitigate slipping. Finally, I built a strong container for the piston to keep it from twisting. Here's how the first test went. To my surprise, it was actually a huge success. Now, remember how I mentioned that I want this piston to work with buttons, levers, and other redstone items? I thought of a really fun and cool way to replicate that. I use this device to detect which redstone mode a user wants. 4 modes can be selected, which I'll show you later. When the user presses this button, the piston will activate in whatever mode is selected. Now here's an interesting challenge. A Minecraft piston can be oriented in several different ways, horizontally, vertically pointing up, and vertically pointing down. I wanted to replicate that too, so I needed to add braces that will support the piston container when the piston is horizontal or even upside down. The piston is getting very close to being finished. I wired everything up so the EV3 controller can communicate with the sensors and motors. With the wiring finished, it was time to finish the piston's walls. Remember the chiseled stone bricks? Those come first. The piston walls will go above the chiseled stone bricks, just like when a piston is sitting on a chiseled stone brick block in Minecraft. Lastly, I added some stickers to help the user know what mode they are selecting. I wrote 200 lines of code using PyBricks and MicroPython, and then the piston was ready to go. Okay, here's button mode. It should extend for a moment and then retract, but not if there's an immovable block in front of it. Lodestone cannot be moved, for example, but birch logs can. Here it goes.
Nice try, but lodestone can't be pushed by a piston.
Yeah, you're out of here. Alright, awesome! The next mode is lever mode, which I'll test with the piston in a different orientation. The piston should extend and remain extended until I push this button again to deactivate the simulated lever. Let's see it work! That worked great! Before I get to the coolest mode, here's Observer with Copper Bulb mode. It's a variation of this simple circuit. When a movable block is detected, the piston should extend, and when the block is removed, it should retract.
The rules haven't changed, silly. Lodestone still can't be pushed by a piston.
Ha! Nice try. Ah, so cool! Finally, here's redstone dust mode. See, in Minecraft, we don't have to be anywhere near a piston to activate it. So I have a remote here, and I can select the mode and activate the piston without being anywhere close. Wow, that's so fun! The final test will be if the piston can be flipped upside down and still work, just like it does in Minecraft. Yes, it does. Share this video to make it go viral, and check out my other working LEGO Minecraft builds. See you again soon!